group 7 elements of fluorine, chlorine, bromine, iodine and astatine are also known as the halogens. They all have 7 electrons in their outermost shell, and when they react, they acquire an electron to give 8 electrons in their outer shells. Consequently, because they gain an electron, they are reduced when they react, since reduction is gain of electrons.
The reactivity of halogens decreases going down the group, since there is less attraction from the nucleus as you move down a group due to increased atomic radius and increased electron shielding. A more reactive halogen can displace a less reactive one. For example, if chlorinated water is added to a solution of potassium bromide, the chlorine, being more reactive, will displace the bromine. In this reaction, you would see the solution turn orange as bromine, Br2, is liberated. This reaction can be written as an ionic equation. With ionic equations, you only include the species that have changed. In this example, the potassium K+ aqueous ion has not changed, and we can therefore leave it out, as it is known as the spectator ion. If we assign oxidation numbers to this reaction, we can work out what has been oxidized and what has been reduced. Chlorine, being an element, has an oxidation number of 0 initially. The oxidation number of the bromide ion will be the same as its charge, that is, -1. When they have reacted, the chloride ion has an oxidation number of -1, and the bromine, being an element, has an oxidation number of 0. Bromine has gone from having an oxidation number of -1 to 0, and because the oxidation number has increased, bromine has been oxidized. The chlorine has gone from having an oxidation number of 0 to -1, and so has been reduced. We say the chlorine is a stronger oxidizing agent than bromine, as chlorine can oxidize bromine. The order of reactivity for the halogens can be worked out by carrying out a series of displacement reactions, where the halogen in water is added to a solution of halide ions. If chlorine water is added to bromide ions, as we have seen, the more reactive chlorine will displace the less reactive bromide, and the bromine will appear as an orange coloration. When chlorine water is added to a solution of iodide ions, once again, the more reactive chlorine will displace the less reactive iodine, and a brown coloration of iodine, I2, will appear. When bromine water is added to chloride, there is no reaction, as the bromine cannot displace the more reactive chlorine, and the resulting solution will be orange in colour due to unreacted bromine. When bromine water is added to iodide ions, there is a reaction, since the more reactive bromine will displace the less reactive iodine, and consequently the solution will turn brown due to the presence of iodine, I2. When iodine is added to both chloride and bromide ions, there is no reaction, as both chlorine and bromine are more reactive than iodine, and the colour of solution in both cases will be brown due to unreacted iodine. To distinguish between the different halogens in solution, an organic solvent like cyclohexane can be added. The halogen present will go into this upper organic layer. Chlorine is pale green in water and also pale green in organic solvent. Bromine is orange in water and also orange in organic solvent. Iodine is brown in water but changes to violet in organic solvent.